Centrally amplified type speakers and horns, such as 25.5 volt, 70.7 volt, or 100 volt speakers and horns, have an input impedance that's directly related to the wattage rating of that speaker or horn with respect to its intended amplifier voltage. In other words, a 70.7 volt horn that's rated at 15 watts will have an input impedance that will produce 15 watts when you apply 70.7 volts to it. If you apply a higher voltage to it, it will produce more than 15 watts, and of course if the horn or speaker is not designed to handle that higher current, then it will damage the horn. But that said, I want to show you an example here of option D. Press D and press enter to go through these first few screens. For this example, I'm going to put in a 70.7 volt horn, 15 watt, and I'm going to put it at the end of 10 miles of wire. So I'll press B to select 70.7 volts. Acceptable power loss, I'm going to start with 10% for this example. And I'm going to put in 15 watts and 10 miles of wire, which would be 52,800 feet. Now I'm going to exit the data entry section by pressing enter, enter. And see what it's selected is 2 gauge wire. 2 gauge wire is required if you're going to put a 15 watt horn at 10 miles distant from the amplifier and you want no more than 10% power loss. And indeed, using 2 gauge wire, your power loss is 9.21%. If we look at all the wire gauges, we press 2 to view all the wire gauges, what you can see is the different power losses that resulted from different size wires. Notice as the wire gets bigger, you have less loss. I press enter. But to get down to my intended 10% or my desired 10%, it had to go all the way down to 2 gauge. 3 gauge resulted in 11.4%, which is higher than 10, of course. But suppose I didn't want to use 2 gauge wire. I wanted to use something a little bit smaller. So I want to evaluate maybe increasing my amplifier voltage to 100 volts. The way I do that, I press 1 for more options, and I press 2 to change the amplifier constant voltage. I'm going to put in 100 volts, and I want to leave my speaker as a 70.7 volt type. Okay, what's happened here is the program had to go down to 11 gauge wire to stay within my 10% or power loss that I desire. And what's happened is with 11 gauge wire, you actually have more than 15 watts across the horn. And you actually have some gain across the horn, so you're in danger of damaging the horn here. You have all sorts of error messages here. It tells you that your speaker type is a 70.7 volt, but your amplifier voltage is 100 volts. It explains that a negative % power loss implies that the actual power across the speaker is greater than the wattage tap setting of the speaker, so you actually have a gain. But why didn't it use a 12 gauge wire? Let's take a look at that. Let's press 2. And we can see what happened is when it got down to 12 gauge, you still had 11.46% loss. So to get within my 10% loss, it had to drop down to 11 gauge, which actually had gain. The 11 gauge wire didn't have enough resistance. 12 gauge wire had too much. So what I can do here, I'm going to press enter, enter. Suppose I determine I can actually endure 20% power loss. Right? So I'm going to change my power loss. I'm going to press 1. And I'll choose option 6, press 6. Change my power loss to 20%. Okay. And now I'm in good shape. I can use 12 gauge wire. And so what this means is if I take a 100 volt output of an amplifier and 10 miles of 12 gauge wire, and at the end of that 10 miles of 12 gauge wire I put a 70.7 volt 15 watt horn, my power loss would only be 11.46%, and I'd have a half a dB loss. I press 8 to end.